Hi, my name is Laura, and I'm going to be presenting my research on the ensemble coding of facial identity. So we know that groups of low-level visual stimuli can be combined into a signal cognitive representation that captures their statistical properties. This is known as ensemble coding. So the effect is also seen for facial identity. However, what we find in these studies is that the ensemble average is encoded alongside the set members. So many studies use complex designs with 4 or more faces, so I sought to investigate the ensemble coding of facial identity at its most basic form. So in experiment 1, I use a minimum of 2 identities, which is the minimum needed for an ensemble to be formed. So I presented participants with 1 or 2 faces to learn, and then present them with a test face, which was either one of the set members, which is also known as an exemplar, the ensemble average, or a filler. And what we find is that in under 1 target conditions, only the exemplar is recognized, which is what we'd expect. And under 2 target conditions, both the exemplar and the average are recognized, with no difference between the two. So this suggests that ensemble coding is occurring, and participants have the capacity to encode 2 faces. However, there's no evidence that the ensemble coding results in superior performance for the average over the exemplar. So some studies have suggested that superior performance for the average can only be found with different images used. So experiment 2 replicated experiment 1, but with different images at learning and test. And again, what we find is that under 1 target conditions, only the exemplar is recognized. But when participants see 2 targets, both the exemplar and the average are recognized at an equal rate. So together, the results from experiment 1 and 2 point to both the exemplar and the ensemble average being encoded at the same time. So what remains unclear is whether this is evidence of ensemble coding, or whether another mechanism such as resemblance can account for these results. One test that has not yet been done is to directly compare the average to the exemplar. So by giving participants 2 faces to choose from in a forced choice paradigm, we can compare how often participants will choose each type of face when the choice is between the average and the exemplar. So in experiment 3, I show participants 1 or 2 targets to learn. I then give them 2 test faces to pick from. This was either the exemplar and a filler, the average and a filler, or the exemplar against the average. And basically, participants had to pick which of the 2 faces most resembled one of the targets that they learned. Now, if participants were encoding the 2 faces separately, and the ensemble was only being picked because of resemblance, then what we'd expect to find in this study is that the exemplar would be picked more often than the ensemble. And this is because the exemplar would have a stronger resemblance to the encoded targets than the ensemble would. But what we actually find is that both the exemplar and the ensemble average are selected at an equal rate. So across these series of experiments, we have found evidence that both the ensemble average and the exemplar are encoded at the same time. So whether this is evidence of ensemble coding, or whether the ensemble coding of facial identity results from another mechanism related to face learning remains unclear. Thank you for listening.